Hello friends, welcome to my channel. Today I will be discussing Leetcode daily challenge problem. It's a medium level problem. Convert BST to a greater T. First, let's read the problem. It is given that given the root of the binary search tree, convert it to a greater tree such that every key of the original BST is changed to the original key plus the sum of all the keys greater than the original key in the BST. Okay. As a remainder, a binary search tree is as a tree that satisfies the three constraints. Left subtree of a node contains only the nodes with keys less than the node's key. It's defining the binary search tree property, and the right subtree of the node contain only nodes with keys greater than the both nodes key. Both the left and right subtrees must also be a binary search tree. It is defining the properties of the binary search tree, and it's also saying that the left subtree and the right subtree must also follow the same binary search tree property. Okay, here is the first example. I have copied this example on the whiteboard for your reference. To solve this kind of questions, first we have to do traversal. Okay, see, it is given that it is given in the question that we have to return the original key plus the sum of all the keys greater than the original key in the BST. We know that in the BST the largest value lies on the right hand side, means in the left part the value that is smaller than the root node lies here in the left subtree, and in the right subtree the values which are greater than the root node lies in the right subtree. So we'll traverse in the right part. We will follow here the reverse of in order traversal. In order traversal we know that it is L and R, and in order reverse is R N R. So first we will traverse in the right direction. Getting this, we will see if the right node exists. Yes, the right node exists, so we will go there, and after this in the right direction we will maintain a variable which is great. Okay, it is used to store the count. It is used to store the sum of the values which are greater than the particular node. Okay, so it was first initialized to 0. Okay, before the start of the program. After going there we see that the right subtree does not exist of the 8th node, and also the left subtree does not exist, so it is the largest value in the BST, so it will be, so great will be updated as 8. Okay, great here will be updated as 8. So now it will go back and it will see right subtree is finished, so we are in N, and L does not exist means left subtree does not exist, so it is the greater node. So greater, the node which is existing greater than 7 is 8, so we have to store the value. It is given here original key plus the sum of all keys greater than the original key in the BST. So original key is 7 and 7 and greater key is 8, so 7 plus 8 which is 15. So here 15 value gets updated here, and here we will write 15 instead of 8 instead of 7, so it will go here the sixth value. Now now we are in N. Okay, we have traversed the right subtree. Now we are in the central node 6, and we see that it is greater than 6 is smaller than 7 and 8, and 7 and 8 are the only two values which is greater than 6, so the its value will be updated as 6 plus 15 which is 21. So great will also be updated as 21, and here instead of 6 21 will be written. Okay, after examining the N we will go to the L, and we will see here neither the right subtree exists, and it is the central node, so it the 5 is less than 6 7 and 8, and the sum of 6 7 8 is 6 plus 7 is 13, and 7 plus 8 is 15. So 15 plus 6 plus 7 is 15. Okay, and 7 plus 8 is 6 plus 7 is 13, 13 plus 8 is 21. So 21 is the sixth value, and 21 plus 5 which is 26. So great value gets updated as 26, and instead of 5 here comes 26. Okay, now it will go back. After this it will go back to the fourth node. Okay, and we have completed the right part of the fourth node, and now we are in the N part. Okay, and we see that the values which are greater than 4 are 6, 5, 7 and 8, and the sum of these values is 6 plus 5 is 11, 11 plus 7 is 18, 18 plus 8 is 20, 18 plus 8 is 26, and 26 plus 4 is 30. So great value will be updated as 30. Okay, and instead of 4 here 30 will be written. Now for the fourth node we have examined the right part and the end part. So we'll go in the left part. On coming on the left part of the first, we will first examine the right part because R and L is a we are following the in order reverse. So we'll go here and we'll see if, is there any right node exist. So the right node is existing here, so we will go here, and now we will see in the 3 the right node does not exist and it is the central node. So the great value will be updated as the values which are greater than 3 are 4, 6, 5, 7, 8, and we have stored these the sum of these values as 30, and its node will be updated as 30 plus 3 because original key plus the value which are greater than the node. So 33 will be here and it will be updated as 33. Okay, now it will go back to the second node, and eh, we will see that the right node we have examined as 3, and which is the central node 2. So we will see the values which are greater than 2, which are 4, 3, 6, 5, 7, 8, 8, and we have stored the sum of these values in the great part. So great here consists of 33, and uh, we will store the now update the great value as 33 plus 2, which is 35. Okay, and here the value will be updated as 35. So now we will go back to the first node. We will see that we have examined the right part of that of this subtree. Now we are in the central node. So the values which are greater than 1 are 2, 3, 4, 5, 6, 7, 8. So we have stored the sum of these values in the great part. So great part contains 35, and now its value will be updated as 35 plus 1, which is 36. Okay, and its value will be updated as 36. Now we will go in the left part and we will see the values which are greater than 0 are 0, 1, 2, 3, 4, 5, 6, 7, 8, and we have stored the sum of these values in the great part which consists of 36, and the values and now the great part will be updated as 36 plus 0, which is 36. Okay, and it will be updated as 36. Now we'll go back and the traversal is finished, and on coming back to the question we can see that the we have stored the values. Now let's go on to the coding part. We will first maintain a global variable of greater, which is used to store the count of the values which are greater than a particular node. Okay, we'll first examine if the root passed is null or not. If the root passed is null, then we will return simply the null because it does not contain any node. Okay, and as I have given you that we will follow the in order reverse. So first we will go in the right subtree. So convert BST will copy from here, and root dot right. After here we will update the value of the root as root dot value is plus greater, the nodes which are greater than the current root value. Okay, and now the greater will be updated as the root dot value, and then we will call on the left subtree part, and after that at last we will return the root node. Okay, let's run the code, and the code runs fine. The solution is accepted. Let's submit the code. Thank you friends for watching this video. If you have any doubt, then you can